Imagine placing a pot on a stove, and it starts heating up instantly, without flames, without glowing coils, and without even warming the surface beneath it. It almost feels like a trick. But induction stoves aren't magic. They're science doing something incredibly efficient and surprisingly elegant. Unlike traditional gas or electric stoves that rely on heat transfer, induction cooking skips a step entirely. It heats the cookware directly. That's why water boils faster, energy is used more efficiently, and the cooktop stays relatively cool to the touch. So how does this futuristic kitchen tool actually work? Let's break it down. Right here, on History of Simple Things. Induction cooking might feel modern, but the concept has been around for over a century. The principle behind it, electromagnetic induction, was discovered in 1831 by physicist Michael Faraday. His experiment showed that a changing magnetic field could generate electricity in a conductor. However, it took a long time before this idea made its way into kitchens. Early demonstrations of induction heating appeared in the early 1900s, mostly in industrial applications like metalworking. It wasn't until the 1970s that induction cooktops were introduced commercially, though they were expensive and not widely adopted. Over the past 2 decades, improvements in electronics and materials have made induction stoves more affordable, efficient, and common in homes around the world. At the heart of an induction stove is a simple but powerful concept: using magnetism to generate heat. Beneath the smooth glass surface of the cooktop is a copper coil. When you turn the stove on, an alternating electric current flows through this coil. This creates a rapidly changing magnetic field above it. Now here's where things get interesting. When you place a pot made of a magnetic material, like cast iron or certain types of stainless steel, on top of the stove, that magnetic field interacts with the metal. This interaction generates tiny electric currents inside the cookware itself. These are called eddy currents. And those currents, they meet resistance inside the metal, which produces heat. So instead of heating the stove, which then heats the pot, induction cooking heats the pot directly from within. One of the most surprising things about induction stoves is that the surface doesn't get nearly as hot as traditional cooktops. That's because the glass surface isn't the source of heat. The energy passes through it and goes straight into the cookware. The only heat you feel on the surface comes from the hot pot sitting on top of it. This has 2 major benefits. First, it makes cooking safer. You're less likely to burn yourself if you accidentally touch the surface. Second, it makes cleanup easier. Spills don't get baked onto a scorching hot surface, so they're much simpler to wipe away. If you've ever tried using an induction stove, you might have noticed something frustrating. Not all cookware works. That's because induction relies on magnetic interaction. Materials like aluminum, copper, and glass don't respond to magnetic fields in the same way, so they won't heat up. For a pot or pan to work on an induction stove, it needs to be ferromagnetic, meaning it can be magnetized. Cast iron works perfectly, and many stainless steel pans are designed with magnetic layers specifically for induction compatibility. A quick way to test your cookware: if a magnet sticks to the bottom, it'll likely work. One of the biggest advantages of induction cooking is speed. Because heat is generated directly inside the cookware, very little energy is wasted. There's no need to first heat up a burner or wait for heat to transfer. As a result, induction stoves can boil water significantly faster than gas or traditional electric stoves. They're also more energy efficient. Gas stoves lose a lot of heat to the surrounding air, while electric coil stoves lose heat through the burner itself. Induction, on the other hand, delivers most of its energy straight into the pot. This efficiency isn't just about convenience, it can also mean lower energy consumption over time. Another reason many people prefer induction stoves is the level of control they offer. With gas, you adjust the flame. With electric stoves, you adjust the heat level and wait for the burner to respond. But with induction, changes happen almost instantly. Lower the setting and the heat drops immediately. Increase it and the pot responds just as quickly. This makes it easier to maintain precise temperatures, whether you're gently melting chocolate or rapidly boiling water. Induction stoves are also known for their built-in safety features. Since they only heat when compatible cookware is present, the stove won't turn on accidentally if there's nothing on it. Many models automatically shut off if a pot is removed. There's also no open flame, which reduces the risk of fire. And because the surface doesn't get extremely hot, it's generally safer in households with children. Of course, induction cooking isn't perfect. The biggest limitation is cookware compatibility. You may need to replace some of your pots and pans if they're not magnetic. Another factor is cost. While prices have dropped over the years, induction stoves can still be more expensive up front compared to traditional options. There's also a slight learning curve. Because the heat response is so fast, cooking times and techniques may need a bit of adjustment. Induction stoves might seem like a modern luxury, but they're really the result of a 200-year-old scientific discovery finally finding its place in everyday life. By using magnetic fields to generate heat directly inside cookware, they offer a faster, cleaner, and more efficient way to cook. No flames, no glowing coils, just energy going exactly where it's needed. So the next time you see water boiling almost instantly on a smooth glass surface, remember, it's not magic. It's physics, working smarter than ever, and it might just be the future of cooking. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.